Hi, this is Dr. Xu teaching mine ventilation for mining engineering college students. In today's video, we will talk about how to use the Vane anemometer for measuring airflow rates. There are two types of anemometers. One is the mechanical anemometer and the other one is an electrical one. The biggest difference is that the mechanical anemometer does not run on batteries and will not generate electric sparks. So it is safe to be used in coal mines where has methane, an explosive gas. The electrical anemometer has the risk of generating electric sparks unless designed specifically to be intrinsically safe, thus normally not safe to be used in an environment that has explosive gases. Generally, the mechanical anemometer can be used in any mine, but we don't use the electrical anemometer in coal mines. Let's firstly look at this mechanical anemometer. The basic principle of the anemometer is that when the moving air passes through it, air pushes the propeller to rotate. The dials here track the number of the spins and convert it to the total distance that air has traveled. We will also need to record the time using a stopwatch from the start to the end of the measurement. Dividing the recorded distance reading from the anemometer by the time measured by the stopwatch, we get the air velocity. Because the way it works, it can only measure air velocity accurately when this is positioned in parallel with the direction of the airflow. So if the air flow direction is like this, we can only position the anemometer in parallel with the direction of the airflow. We cannot position it like this when the airflow is this. We cannot position it like this. We can only position it in parallel with the direction of the airflow. On the top here, this is the lock button. If it pushes to one side, the handles on the dial do not move because it is locked. So you can see, even if the propellers are spinning, the hands on the dial do not move. When we start the measurement, we also need to push this reset button. So the reset button, if you push it, it will reset the dial hand to 0. Every time we start the measurement, we need to reset it to 0. If the longest hand does not align to 0 after pressing this reset button, here has a screw that we can adjust to align this hand to the 0 position. Also, air needs to pass the anemometer in the correct direction. We need to decide if this side faces the direction of the flow or this side faces the direction of the flow. To determine this, firstly we look at the side of the anemometer. Sometimes there will be arrows pointing to the direction of the flow. If there is that arrow, we need to make sure air flow through the anemometer and pass it in the direction indicated by the arrows. But in this anemometer, we cannot find that arrow. This model doesn't have the arrow. We need a different method to find the correct way of airflow direction. The second method we do it is to blow some air. Make sure we unlock it. We blow some air. As you can see, I blow air from this direction, but the hand is rotating in the reverse direction. That means air is not passing the anemometer in the correct direction. And if I blow air from the back, as you can see, now the hand is moving in the clockwise direction. That means air is supposed to move from the back of the anemometer to the front of the anemometer. Before using the anemometer, we also need to know the record unit of the dial. This anemometer has 3 dials. On the largest dial, it reads numbers less than 100. The left small dial is the thousandth dial, and the right small dial is the hundredth dial. For one round, the largest hand moves. The 100 hand moves one scale up. Once the 100 hand moves one round, the 1000 hand will move one scale up and point to 1000. Before using this anemometer, we also need to know the record unit of the dial. We can look at the calibration chart on the side of the anemometer here. Here it says the final velocity correction are based on FPM, which is feet per minute. So we know the dial reading is in feet. Let's now do a simple point air velocity measurement. I will use this stopwatch to record time. Firstly, lock the anemometer and reset the anemometer, and then reset the stopwatch. Air is flowing from that side to that side. So if I want to measure the air velocity here, I will just position it in the correct direction. I will use one hand holding the start button of the stopwatch and another finger holding the unlock button on the anemometer. Place the anemometer at the right position, start the stopwatch, at the same time unlock the anemometer. For accurate measurement, it is better to measure more than 1 minute. At the end of the measurement, lock the anemometer. At the same time, stop the stopwatch. Okay, now we have got the readings from the anemometer. Firstly, we read the 1000 hand. There's nothing there. And then we read the 100 hand. It is 100. And then we read this largest hand. It is 66. So this indicates 166 feet. And look at the time, we have got 116 seconds. So now we need to calculate the air velocity by dividing 166 feet by 116 seconds. 166 feet divided by 116 seconds. So this is 1.4 feet per second. We need to convert that to feet per minute because this correction chart correct the reading based on feet per minute. Multiply by 60, that is feet per minute. So about 85.8 feet per minute. So from the reading on the anemometer, by dividing it by the time I have recorded on the stopwatch and converted to feet per minute, we have got 85.8 feet per minute. And then we will need to correct the reading by using this calibration chart or correction chart. On this correction chart, it has different correction factors for different velocity range. 85.8 lays between 70 and 90. We will just use the correction factor for 70. So for 70, here the correction factor is plus 15. So 85.8 plus 15, that's 100.8. So the final velocity that we have measured here is going to be 100.8 feet per minute. Thank you very much for watching. This is Dr. Xu. If you like the video, please give it a thumb up, subscribe my channel, and share it to your friend who may benefit from this video as well. I will see you in the next video. Bye for now.